When I visited Susana in Alcalá, she suggested me to do an episode about the Higgs boson. The problem is I don't think it's possible to explain it clearly in just one episode. So from today on, I'm going to do a series of episodes that I want to call Quantum Leap, in which we will travel from classical mechanics into the quantum world. This is Monterey, and come with me to my cosmic kingdom. We all live in a classical world. No matter what they tell us, that the reality is a quantum reality, for us, it's just classic. That is the reason why it took so many years, 2,400 years of science, to get into the depths of the quantum world. What do I mean by classic reality, by classical mechanics? It's basically Newton's laws and all the complicated ways of formulating them. Because first they came the Newton's law, then the Lagrangian formalism, and then the Hamiltonian formalism, which was just close to the gate of the quantum mechanics. So Newton's laws are simple. There are only three, and that's why they are so beautiful. The first one is just something that is moving, it will keep its states of movement. And remember, being not moving is just a state of movement. The second one is simple. It means that the acceleration that an object has is just proportional to the force exerted on the object. And the third one, it means that if you just press some object with a certain force, the object will exert a force in the same value as the one you are exerting, but with different direction. That's it. Simple, isn't it? Just we have a universe in which we have waves like the ones you can see in this lake, and a universe of particles like this chestnut. And the funny thing is, like in classical reality, no one will doubt that this chestnut is here. I can just pinpoint its position easily because it's here. And also, I can just calculate its velocity, at least to respect to myself. I know now it's not moving. Those are things that are obvious in the classical world. No one will just say that this tree behind me, this one, is there. Of course it's there, and it's not moving. Of course it's not moving. Yeah, but that is the classical reality. Also, if I throw this chestnut, it will create a ripple on the pond. It can create a wave because it carries energy. And the amount of energy it carries is determined by the laws of classical mechanics. What's more, I can give within, my power with my arm, I can give it any possible energy from 0 to the maximum energy I have in my arm. Any possible value. Those are things that are obvious in our classical world, but when we take our quantum leap, you will see it's not so trivial. Also, I'm following the famous Revere cat, and you can see an episode of HMM Revere Log here if you want it. No one will doubt that all these geese here are alive. Yeah, they're alive. You can see them. They are beautiful. They are drinking water, just having their morning routine, and all of them are alive. No one will consider an entangled state of a live and a dead goose. Because in our classical world, either you are in one state or you are in another. And what's more, it doesn't depend who is watching the geese. It doesn't depend if it's me or if it's my friend Susana that is watching them. It's just classical. And sometimes we forget that classical physics is really good, and it helps to explain our environment pretty well. I mean, we went to the moon using Newton's law, and we landed an aircraft in the moon with incredible precision. We didn't need relativity or quantum mechanics. Now we use quantum mechanics a lot, but we don't see it. For instance, the reason why I'm able to record this in my solid state device aka phone, it's because we are using the quantum theory in semiconductors to just do transistors. And I have probably left a few things, a few interesting bits of the classical work in this brief summary of what is normally the first 2 years of a physics undergrad. Of course, if you are interested in any of them, just please let me know, and I will be very, very happy to do an episode. I love people suggesting topics because it makes my life easier. And remember, I'm going to cross this bridge from the classical to the quantum world. So new year, we're going to be deep in our boots into quantum math. I hope you like this episode, and see you guys next year. Have a good Christmas. Bye bye.